Welcome to Brain Vision.
Problem 28.4, we have an alpha particle, that's this here, and an electron that move in opposite directions from the same point. And we have each with the same speed, and we're supposed to find the magnitude and direction of the total magnetic field of these charges that they produce at point P, which is a certain distance away, 8.65 nanometers from each charge. Okay, so we need to solve this using the equation for the B field of a moving point charge. So that equation is B equal to mu naught over 4 pi. And we have Q vector for velocity vector cross r hat over r squared. Okay, so Q, that's just the charge of each of them. V, that's the vector for each of them in different directions, and r is just this distance given. R hat is going to be the vector extending from their origin point out to the point P. So we need to write down what this is going to be for each of them. So I'm going to start off with the equation for the alpha particle. So that's going to be mu naught over 4 pi, and it's going to be Q is 2e, so that's going to be electron charge here. And then we have the V value for V, 2.5 times 10 to the 5, and we need to write down what the cross product, that second part of that cross product, is going to be the sine of the angle between them. So that's going to be sine of 140 degrees, and that's going to be over the distance r squared. So that's the B field for the alpha particle. Now we need to write down what the B field is for the electron and add them together. So that's mu naught over 4 pi. We just have negative E because the charge is negative. We have the same velocity. And then this time the angle between them, if this is our positive direction going clockwise, then going from vector V to vector R is going to be negative 40 degrees. Excuse me, going from the vector R to the vector V, it's going to be negative 40 degrees, because that is equivalent to taking vector V from vector R and going counterclockwise 360 degrees minus that 40 degrees that's remaining. So that's why we have sine of negative 40 degrees, and that's over r squared. So there are some common terms we can factor out. We have mu naught over 4 pi. We have E, the electron charge. We have V over r squared. And what we have left in brackets here is 2 sine of 140 degrees. And then minus the sine of negative 40 degrees. Okay, so what we're left here is just numbers that we can plug in given what we have up here and knowing what these constants are. So that's going to be 5.353 times 10 to the negative 5 Tesla. And in brackets, we have 1.928, making sure that we're calculating with degrees, not radians. Okay, and that should be 1.03 times 10 to negative 4 Tesla. And what direction is this going to be? So following our right-hand rule for the alpha particle, that's going to be out of the page at point P. And following the right-hand rule for the electron, that's going to be out of the page at point P. So they both contribute to having the magnetic field point out of the page. So I'll write K hat here.